are probably something you've done before. So even like way back, like math, like 4 or 5, you probably learned about parallel lines, which are just lines that would never touch each other if they went forever. They'll never cross each other, they'll never intersect. Why do parallel lines never intersect? I mean, you can look at it and you'd be like, yeah, they look like they'll never touch each other. But why do they actually never cross each other? They're going at the same angle or the same slope, the same steepness, right? These lines would never cross each other because they have the exact level of steepness of each other or the exact same slope. So when you talk about parallel lines, you're talking about lines with slopes that are identical. It says that right here. I'm going to give you an example of identical slopes that don't look like identical slopes. So M1, we'll pretend this is line 1 right here. So then slope 1 could be 3 over 5. M2, assuming that this is line right here, must have the same slope because they're parallel lines. But the same slope doesn't always look like the same slope. They could say that M2 is 6 over 10. And we've talked about this in a couple other lessons where slopes can be the same thing but look different. And how can we check to make sure they're the same? What do we have to do to one of those slopes? Reduce it, right? These don't look the same, but in reality, this one can just be reduced. Both those numbers, the 6 and the 10, can both be divided by 2 to become 3 over 5. Worst case scenario, you put it in your calculator and you'll math fraction. They're actually the same slope. It's going to be really important that you always reduce slopes, because that's how you're going to check to see if things are parallel or not. Parallel lines are easy. They're the easiest set of examples that we use. Perpendicular lines are a little bit more confusing. Perpendicular lines look like this. And they always make a 90-degree angle. They're basically lines that are like completely opposite of each other. I'll call this one L1, this one L2. And you can see that line 1 is going up and line 2 is going down at almost the exact same rate, just the opposite way. We have an actual term, and a mathematical term for that. It's called negative reciprocal. It means opposite symbol. So if it was positive, now it's negative. If it was negative, now it's positive. And reciprocal means it's a fraction, but flipped upside down. So perpendicular lines have negative reciprocal slopes. How that looks. Do an example. Slope 1. So for line 1, let's say it's 2 over. If we want to have a perpendicular line, the slope has to be opposite symbol. So this one was positive, so what's my new one going to be? Negative. That's where it's the negative reciprocal. That's the term negative, means the opposite sign. Reciprocal means flip the fraction. So instead of 2 over 3, it becomes 3 over 2. That means negative reciprocal. Again, you could do a negative reciprocal and have different numbers that just need to be reduced. So make sure you're reducing all of your numbers to check to see if they're actually negative reciprocals or not. Also, make sure they're fractions. Some people really like this trick at the bottom. I personally have never used it, I don't think, but I've seen a lot of people use it. And it's a quick way to check if something's a negative reciprocal. If you have something that's negative reciprocal, then when you multiply them together, you should get negative 1 every time. If those two things multiplied together don't equal negative 1, they're not negative reciprocals of each other. So it's a quick way to check if something is a negative reciprocal or not. Just multiply them together. Multiply, yeah, put a little dot there. Make sure if you're doing it in your calculator, you put brackets around the fractions so you don't accidentally do something crazy. Okay, we're going to have a couple slides worth of questions just to see how this actually looks. So all we've learned is parallel lines, same slope, perpendicular lines, negative reciprocals. Here's a question. It says, consider the line segment AC with a slope of 3 over 4. So that means slope of AC equals 3 over 4. What is a slope of line segment GH, which would make it parallel to AC? If you want to be parallel to AC, what does your slope have to be? Listen. It has to be the exact same, so it has to be 3 over 4. That's perfect. Right? Parallel means same slope. So a slope for GH, which would make it parallel to AC, is 3 over 4. Now question B says, what is another slope for GH, which would still make it parallel? 9 over 12 works. How'd you get 9 over 12? So he's right. 9 over 12 would work. Yeah. All he did was he took his slope of 3 over 4, and he times them by the same number. In this case, 3. You could have times it by any number, and you would have found another slope that worked.
It's like 6 over 8.
Yeah, 6 over 8 would have worked. That's just multiplying by 2. Right? 30 over 40 would work. That's multiplying it by 10. These are all the same number. It's just a different fraction. Okay, so just remember, fractions can still be the same, but look different. And you need to put in your calculator to double check it. C. What is the slope for line segment BF, which would make it perpendicular to AC? So you have slope BF, and you want it to be perpendicular. Perpendicular means negative reciprocal. So what's the negative reciprocal to AC? AC was 3 over 4. What do you think it should be?
Negative over 3.
Perfect. You changed the symbol. So it was a positive slope. Now it's a negative slope. And then you flip the fraction. Instead of 3 over 4, it became 4 over 3. This would be perpendicular to 3 over 4. Anybody have any questions about that? Buddha. All right. Last question here. This is kind of a typical question you would get. It gives you 2 points, right? So it says if P is 0.4, 7, and Q is 0.6, negative 2, find the slope of a line passing through P and Q. They've given you 2 points, and they're asking you to find the slope. If they've given you 2 points and they want to find slope, what do you have to use? You don't have to know it, just what is it? The formula. The formula for slope was y2 minus y1 over x2 minus x1. It'll always be provided to you, quiz or test, so don't you worry about that. What I do want you to try is to see if you can remember how to calculate slope when given 2 points. So I'm going to give you the opportunity to find the slope between point P and Q using the formula that's right there for you. So give it a shot, see how you do. To calculate slope when given 2 points, you have to pick one point as 0.1, another point as 0.2. I would just make the first one 0.1. So I'm going to say this is 0.1, meaning that this is x1, y1. I pick the other one to be 0.2, meaning this is x2, y2. If you chose it the other way around, are you wrong? No, it's perfectly okay to say this is 0.2 and that's 0.1, or vice versa. What's important is that you're consistent. If you're calling P 0.1, then it's x1 and y1. You can't reverse it, the x1, y2 all of a sudden. Now we just plug things into our formula. So our formula is y2, negative 2, minus y1, that's 7. Divided by x2 was 6, x1 was 4. When calculating this, you just break it up into the top and the bottom, right? So you go negative 2 minus 7 equals negative 9 in your calculator. And in the denominator, 6 minus 4 is positive 2. Negative 9 over 2 should have been your slope between point P and Q. Awesome. Part B. Find the slope of a line that would be parallel to line segment PQ. Parallel means they should have the same slope, so that a slope that would be parallel to PQ would be negative 9 over 2. You could have more than that, right? You could also have negative 18 over 4. Right? All you have to do is multiply the top and the bottom by a number. As long as it's the same number, you should be getting a fraction that's equivalent to it. Part C, which is labeled Part B for some reason. A little bit of a typo. Find the slope of a line that would be perpendicular to the segment PQ. What's perpendicular mean I have to do? Negative reciprocal. So if the slope of PQ was negative 9 over 2, my new slope, which would make it perpendicular to that PQ line, would have to be positive, right? Because it's the opposite. This one was negative, now I'm positive. And then you flip it, so it would be positive 2 over 9. That's a slope that would be perpendicular to PQ. It was negative, now it's positive. That messes some people up sometimes. When it says negative reciprocal, that just means different symbol and then flip it. If this was a test or a quiz, and this was a question, they basically would scrap all of this in front. What they would say is, if P is 0.47 and Q is 6 comma negative 2, find a slope that would be perpendicular to PQ. See how our question, it led us to be able to figure it out nicely? Normally, they wouldn't give you these leading questions to get there. You would have to know, okay, if I want to be perpendicular, I need to figure out what the original slope was. Then I need to take the original slope and flip it and change the symbol. That would be all on you. It wouldn't be part A of a question. So just know when you read a question, it says, find the slope that's perpendicular. That means find the original slope and then find the perpendicular to it. All right, that's it for the perpendicular parallel lines. Tomorrow, you're going to have a quiz to start class. The quiz will be on everything we've done.